Hey guys, this is John, and I've got Mike with me,
Hey, how are you?
and we are going to take a look at storage within OpenShift today. Container native storage is what we're going to be talking about. And Mike, have you heard about container native storage?
I've heard about it, but I've been having a hard time getting my head around it, so I'm glad you're taking the time to explain it to me.
Yeah, I've got a simple picture here on the screen, but the high level elevator pitch of container native storage is that it automates and it simplifies the storage environment, the storage infrastructure within OpenShift. So what does that mean? Did you know, for example, Mike, that if a developer wanted to request storage, there was at least 3 or 4 steps they had to go through in order to get their storage?
I did not know that.
That's very true. They have to create a claim. That claim has to be attached to a storage class, and it has to provision an actual volume, a persistent volume, and that persistent volume has to live on some kind of a storage environment, iSCSI or NFS or something else. And each of those elements is traditionally done manually in a pre-provisioned format or in an ad hoc fashion, but it's very site specific. Container native storage has standardized the way storage works within OpenShift and makes all of those steps automatic. So you can see as we log into the OpenShift environment what we've got to work with today and how this is all automated. So we'll move away from this picture and we'll jump right into our OpenShift environment. And you can see that we've logged in with an administrative type user that has access to see more than just a few projects. In fact, there's one particular project known as the Container Native Storage Project that has some assets in there that we want to take a look at. So, question for you, Mike, would you be satisfied if your data was only stored once and didn't have any backups or redundancies built into it?
No, I would not.
Well, fear not, because container native storage takes good care of your application's data and it stores multiple copies of it. Um, the part we're looking at right now is the front end of it, and if you scroll down on the page, you can see that there's the back end of it. There are 3 back ends, which means that by default, when an application requests storage, that storage will be replicated and put on each of the systems for high availability purposes. So we're
Cool.
using Red Hat's Gluster storage. Container native storage has a dependency on Red Hat Gluster storage, and the front end is known as Haketi, and that provides a RESTful API for creating, removing, and resizing storage. So should we get to work and go ahead and create a new application to demonstrate the simplicity?
Yeah, let's do that.
Great. So in OpenShift parlance, we need to go ahead and create a project, and that project will contain all of the objects associated with our application. Why don't we call this CNS demo? And for our project, um, we'll go ahead and serve out some web, some HTML type data. You can see that we've landed on the catalog, the template browser, where we can look for example applications that are pre-built and quick starts. If we filter on HTTPD, then we'll see that there's a static web server image that we can use as a simple example. All of these parameters could be left as their defaults. There's only one that I really want to change, which is the name. All of the other parameters have to deal with where the template is coming from, what namespace the template is coming from, and if there's any parameters around how many CPU or memory cycles this application can consume. So let's call this CNS demo.
So then just click create.
That's right, pretty simple. That'll land us on a success page, something is happening page, a build is going on in the background, and we can observe the progress of that build if we continue to the overview. You'll see that now the project has several things populated in it, several rectangles and boxes, and we'll begin to describe these here in a moment. Starting from the bottom of the page, there's a larger rectangular that represents the pods. Those are also known as containers, like Docker containers. And above that, there's a title bar HTTPD example, and that has a link you could click on to link out to, which OpenShift has automatically created um, a DNS entry and allowed us to go and look at the contents coming from that static HTTPD web server. But we want to go ahead and put some content into this, and so hence we want to create a persistent volume store so that we could have multiple web front ends scale this out. And if for whatever reason we wanted to remove the website but retain the data, we would have separation between those two things.
All
So in
right.
order to add storage, oh, I apologize. Go ahead, Mike.
No, I said okay. Yeah. Go on.
So in order to add storage here, the easiest way to do it is to modify the deployment configuration. The deployment configuration can be found in the Applications button on the left-hand side and clicking on Deployments. And the deployment is, there's a single deployment configuration here. We can go ahead and click on that. The deployment configuration has some of the variables that we saw on the earlier screen about how much CPU and memory, and that's listed on the Configuration tab. So if you click into the Configuration tab, we can make changes to what this is set up as. One of the most important things is at the bottom of this where it has a reference to the storage of the application, and there is no storage, but there's a link to add storage. This comes out of the box with container native storage. So by clicking on container native storage, we begin to walk through some of those developer-centric elements that we saw on the original image, which is creating a claim that claim will be satisfied by a back-end persistent volume. Now in this environment, we have a single class of storage, a gold class of storage, but for larger environments, we have the ability to instantiate multiple different tiers of storage, bronze and silver and gold, and do different types of performance and data protection against those. But we simply need to provide a name for this claim at this point, and an access mode and a capacity. I like to use access mode RWX, which means that we could have multiple pods reading and writing from this concurrently. And the size, we just need a small one so we can use a single gigabyte. Or after we've created our claim, we want to make sure that this persistent volume, this 1 gigabyte of space, is mounted into our pods at the appropriate location. Because we're using the example HTTPD container, we need to mount the storage into the location that that web server is expecting, and that path is /opt/approot/source. And we'll even go one step further and make a demo subdirectory within there so that we can have isolation between what our persistent volume is providing and what may have been in there already. Great. All the other choices are optional, and we can go ahead and proceed. So by making that change to the deployment configuration, it's been versioned, and now we have a new version of the deployment configuration. We can see that if we click back on the History tab, we should have version 2 available to us now. And it's been active as of a few seconds ago. And one step further, if we look on the overview page of the project, we'll see that we have a new pod that has been created. The old pod was torn down, and the new pod with the 1 gigabyte of storage and the mount at the appropriate mount location has been created. Let's go ahead and look at that pod by clicking on the donut, and we can get its unique name, which we'll need in the next step. The unique name is at the top of the page. So the next step, now that we have the 1 gigabyte of storage, is to actually put something into the storage, into the container. We'll use the command line and rsync to copy some pre-existing website data up into there. And so on our local laptop here, what we have is we have a website folder that has a simple demonstration website. And if we use the OC rsync command and give it the source directory and the destination pod and destination directory, it'll go ahead and copy the contents up there for us. A couple of fonts, a couple of HTML and style sheets, and we're ready to go. So at this point, let's go and see that our new storage has been highlighted. Um, I also like to, at this point, log into the pod and show the available disk space just to show how the persistent volume was attached into the container. And I'll typically do that using the OC RSH command and the name of the pod to RSH into it. And once we get logged in, we'll do a simple df-h to show how much available disk space we have. And if we look towards the bottom, we can see that there's a mount point from a remote file server with a gigabyte of capacity, and we've consumed some of it with our sample application. We could even CD into that directory and list the files, which would show the same output as our sync. Yep, index.html makes reference to a few style sheets and images in the container native storage directory. And so we can go ahead and view that from our browser if we click on the OpenShift overview page, project overview type icon, and then click on the route. The automatically created DNS entry will take us to where we need to be, and we just need to put the /demo at the end of it. Look
Very
at that.
nice.
There's our fancy web page.
So what happens if one of my pods fails for some reason?
If one of your pods fails, that will be noticed by OpenShift, and OpenShift will take responsibility for recreating a new pod to take its place. We can demonstrate that if you like.
Yeah, could we see that happen?
Yeah, so let's go ahead and switch back to the tab of the OpenShift console. And we have a single pod running right now, so you can go ahead and click on that pod donut and show the list of pods. And we'll make note of the name. This pod ends in the name NDQ, and then there's an actions button in the top right hand side. We can go ahead and delete this pod, and whether we delete it manually or something bad happens to the process, OpenShift will recognize that, and OpenShift will recognize that we wanted to have one of these running, and it will automatically recreate a new pod. And you saw that it built one just that quick. If you go back into the overview, you'll see that there's a new pod with a new name. And click on the pod donut. Where previously we had NDQ, now we have 90X. And the other nice thing about container native storage is that it allows you to do all of the different types of storage from read write many, read write once, read only. So if we wanted to scale our application, it's as simple as asking OpenShift to create more images or more pods to support the traffic of the web load. And we can do that on the overview page. There's an up and down arrow. We can scale this application. Yep. So by scaling it to 2 pods, it'll create a new pod, and it will also, in the new pod, mount our persistent volume and make the storage available.
So I would see the same website regardless of which pod I went through.
That's right. And in the back end, OpenShift is taking care of the load balancing from the end users to the supporting services. Built-in load balancing.
Huh, that's pretty slick.
That, in a nutshell, is the automation and the simplicity of using container native storage.
Excellent. Thanks, John.